66.
6640.
Your future lies in 6640.
66 books by 40 authors, and yet we now discover it's an integrated message system from outside our time domain.
Welcome to 6640, Dr. Chuck Missler's daily radio program connecting the Bible to your life and the world around you. This series is entitled, Learn the Bible in 24 Hours. In today's study, Dr. Missler continues his session entitled, The Fall of Man.
One of the questions that we ask ourselves is, when did Satan fall? When we get to chapter 3 of Genesis, he's already a fallen creature. We know he wasn't always fallen when we study Isaiah and Ezekiel and other sources of information about him. So one of the questions is, when did he fall? And the suggestion is maybe there was some incidence between verse 1 and 2, because these terms, without form and void, are always dealt where they occur elsewhere. It's without form and void as a form of judgment. So there are all kinds of conjectures that come out of that. Be careful with those, but recognize that there are these strange views. But the first direct quote of God in the Scripture is the 3rd verse. God said, "Let light be," is what he actually said. Let there be light. And there was light. It's interesting that light itself is one of the most profound mysteries in science. The speed of light is usually represented by the letter C by tradition. Measurements of the speed of light are in themselves an interesting controversy. See, in the 17th century, Kepler and Descartes and so forth, the experts in that day, believed that light was instantaneous, or putting it another way, that the speed of light was infinite, very high, very fast. And that was the conventional wisdom. But in 1677, a Danish astronomer by the name of Olaf Rømer measured the elapsed time between eclipses of Jupiter with one of its moons. And there's ways to do that at different places in its orbit, which gives you a way of measuring the speed of light over very large distances. And by taking advantage of that, he measured the speed of light and discovered it was finite. He was poo-pooed by the physicists for 50 years. They laughed at this foolishness that the speed of light was finite, a finite number. It was an Englishman by the name of James Bradley, 60 years later, that confirmed Rømer's work, and it was generally very reluctantly accepted by the physics community that light had a finite speed. Over the last 300 years, the speed of light has been measured at least 164 times by 16 different methods, and as we examine the data for that, we find some surprising things. There's a delightful friend of mine by the name of Barry Setterfield in Australia that more than 10 years ago explored this issue and published some papers in this area. And he was joined by Trevor Norman. Barry Setterfield and Trevor Norman did an analysis. What they did is they gathered the raw data from these classic experiments through history, and they had examined them carefully. And they discovered Rømer's information with the Io eclipse, his measurement that concluded that the speed of light was 307,600 kilometers per second, with an error band of about 5,400 kilometers either way. And okay. In 1875, 2 centuries later, Harvard University, using essentially the same method, measured it, and it was 299,921 kilometers per second, with an error band of only 13, because obviously technology had improved in those 2 centuries. In 1983, the National Bureau of Standards, using a laser technique, measured the speed of light as 299,792.4586 plus or minus 0.00003 kilometers per second. In other words, very, very small error band. But what's interesting, if you stand back and examine these numbers, you'll notice that the means don't even overlap. That Harvard's analysis fell outside the error band of Rømer's and all the way down. So a Canadian mathematician by the name of Alan Montgomery analyzed all this data statistically, and he also concluded that the speed of light's been slowing down. In fact, it follows a cosecant squared curve with better than a 99% correlation factor. Now, this implies that the speed of light's been slowing down. And if you go backwards and say, okay, what was it earlier? It was apparently 10 to 30% faster in the time of Christ. It was twice as fast in the days of Solomon. It was 4 times as fast in the days of Abraham, and 10 million times faster prior to 3000 BC. And incidentally, there are similar trends in 475 measurements of 11 other atomic quantities by 25 different methods that imply the same thing. It's interesting that some years ago, of course, we developed a friendship with Barry Setterfield, and we included many of these discoveries in our materials, and got a lot of guffaws from some of my friends, Christian physicists, that tried to advise me, Chuck, don't buy into that. That's foolishness. Any physicist knows that the speed of light's a constant. It's not variable. And we caught a lot of criticism from some of these friends for a number of years, better part of 10 years. But in the last 2 years, there have been a number of articles in reputable scientific journals where they have now discovered the speed of light is not a constant. One of the things that disturbs me about these articles that you find in the press is there are many of them now that recognize the reality that the speed of light is a variable and has been slowing down. What's disturbing that none of them acknowledge the pioneering work of Barry Setterfield and Trevor Norman, who've taken this abuse over the decades. You'll discover that physicists cling to their beliefs with the same tenacity that theologians do. And it's not at all objective. But let's get into some other confirmations. The French Astronomical Journal back in 1927 suggested some of these things. Tom Flandern at the U.S. Naval Observatory noticed that the atomic clocks are slowing down relative to orbital clocks. And there's some Russians also that have published in this area independent of Setterfield. So this is not a harebrained idea of a couple of Australians. It's very real. Now, the definition of time itself changed in 1967. Up until 1967, a second of time was defined in terms of one Earth orbit around the sun. A small fraction of that, obviously. After 1967, the second was redefined as a number of oscillations of the cesium-133 atom. And see, if atomic clocks are correct, then the orbital speeds of Mercury and Venus and Mars are increasing, which of course is impossible. If the gravitational constant is truly constant, then atomic vibrations and the speed of light are decreasing. And see, if a planet's orbital speed is increased, it would violate the law of conservation of energy. If atomic clocks are correct, the gravitational constant would change, and no such variations have been detected. So this has some profound implications in terms of the very fabric of our reality here. See, if atomic frequencies are decreasing, then 5 properties of the atom, such as Planck's constant and others, would also be changing. And statistical studies support both the magnitude and direction of these changes. There's another thing that's happening in the field of physics you should be sensitive to. The more you know about what's going on in science, the more comfortable Genesis 1 reads. There's a thing called Hubble's law. That's why the space telescope was named after Edwin Hubble. Hubble's law was because they observe that the spectra, the light spectra of stars, shift to the red, and apparently shifts to the red in proportion to its distance away. They've always assumed that that was like a Doppler effect. A siren sounds higher pitched as it comes at you and lower pitched as it moves away. They call that the Doppler effect in sound. They felt the same things happening with light, that the light shifted to the red because these things are moving away from us, longer wavelength. Except a couple of guys, Halton Arp in Germany and William Tift in the University of Arizona, have spent the last several decades collecting data, precise data, about the red shifts. And they've discovered that some of them aren't so well behaved. See, Hubble's law postulated that this whole idea that the red shift is caused by an expanding universe. And that's why he's honored by the space telescope being named after him and so forth. Except William Tift has discovered that the red shifts are quantized. They're always a multiple of a definitive number. In other words, sort of like the keys of a piano. You can only get certain keys by hitting the key, unlike a violin where you can get any tone you want. A piano, you've got discrete choices. The red shift has that character. In other words, it's digital. And so it turns out that the red shift may actually be evidence of a change in the fabric of space itself. It's an atomic effect rather than a recessional velocity effect. That's just a conjecture at this point, but you should understand the whole field of astronomy is based on Hubble's law, and the rug's been pulled out from under that. Well, going on in Genesis, God said, "Let there be light," and there was light, and God saw the light that it was good, and divided the light from the darkness, and he called the light day, and the darkness he called night. And the evening and the morning were the day one. The subsequent days are relative, second day, third day, fourth day, but this one has a unique designation. It is the first in existence, day one. Also, God divided the light from the darkness. We could talk a lot about that. Most of us think that darkness is simply the absence of light, except now we discover that darkness itself has a property. That's why we have black holes. You can have a gravitational effect out of which no light can emerge. So it's not as simple as it first seems. But there's another thing I want to call your attention to. It says the evening and the morning were day one. The word evening in Hebrew is erev, and the word morning is boker. And we understand erev and boker to be evening and morning, because that's its usage in modern Hebrew. But we'll run into a strange event when we get to the seventh day, because there is no evening and morning. And that's a clue, perhaps, that the word erev and boker in its original context meant something other than evening and morning, and came to mean evening and morning subsequently. Let's explore these two terms a little more carefully, because neither of these occur on the seventh day. Erev actually speaks to obscuration. Mathematically, it's increasing entropy. When encroaching darkness began to deny our ability to discern forms or shapes and identities, hence this became a term for twilight, a time of approaching darkness or ambiguity, confusion. So Erev had its initial concept of obscuration, and that's what's a natural term for evening twilight, if you will. At sunset, that marks the duration of impurity, when a ceremonially unclean person became clean again, and so forth. So we'll discover that the demarcation in the Hebrew world was Erev, the evening, not midnight or morning as we think of it in our world. So the Erev became the beginning of the Hebrew day, but it's a term for evening, because it's a time when there's encroaching darkness and so forth. Okay. The word boker is just the opposite. Boker really means becoming discernible, distinguishable, visible, the perception of order. It's as if you're getting up in the morning and you can begin to see, gee, there are things out there. Let's say if you've ever arrived very late at night at some strange place and went to bed, then in the morning you get up and you look around and you begin, wow, I didn't know that mountain was there. That as the light comes, you can begin to discern. So that's mathematically a form of decreasing entropy, of decreasing randomness. So it has an attendant ability to discern forms, shapes, distinct identities, breaking forth of light, and revealing things, in effect. So that's why it comes to mean dawn or morning. I'm going to suggest to you that these terms have a more fundamental meaning and have come to colloquially mean evening and morning. So we need to understand one of the sciences that's emerging in modern times is probably the most telling of all the sciences, and that's the information sciences. As we understand communication theory, information theory with computers and the rest, and that's been, of course, my personal field of specialization. We obviously can think of disorder and order. We all know what order looks like. We know what disorder looks like. On a Saturday, you clean up the closet. Or at school, you clean up your locker every once in a while. You go from the confusion, you try to get things a little bit more organized, or a woman's purse, whatever. There's a thing called noise, useless change, in contrast to signal, which is carrying information. See, on the right side here, whether it's order or signal, that's information. Disorder or noise is randomness or entropy. Cacophony, sounds that make no sense at all, in contrast to organized sounds, which we call music. There's chaos, in contrast to cosmos. The Greek word cosmos is used of the world, for example. It means to bring order out of chaos. It's the root, of course, to the word cosmetics, but I won't go there. We'll move on here. So on the left side, you got disorder, noise, cacophony, chaos. That's forms of randomness. On the right side, you got order, signals, music, cosmos itself, design. So the disorder, the collective term for that is entropy, randomness, confusion. And in contrast to that, you have information, things that carry intelligence. And the direction is always in the direction of entropy. Things are always winding down. It's as if the entire universe is like a clock that's been wound up that's winding down. We always go from order to disorder. You have to put energy in to go the other way. The natural trend is towards entropy. When you take information and add confusion to it, or you put some noise into it, it degrades in the direction of entropy. If we do an entropy profile of the universe, I'm going to have entropy going upside down. Maximum entropy is the bottom of this chart, and order is at the top, if you will. And so entropy is going downhill, order is going uphill, okay? And so we have erev, which is obscurity and disorder, which later comes to mean evening, and boker, which means orderly, it's discernible, that's morning. And it's my suspicion that erev and boker define discrete steps in defining creation. We have the view that there was an event that caused a disruption between the spiritual and physical world. I'll come to that shortly. But it's interesting, when you get to day 7, the Hebrew translation of that passage, in the Onkelos translation, is that God imposed a unified order on the universe on day 7. The main creation in day 1 is let light be, okay? Let's go to day 2, or second day more precisely. And God said, let there be a firmament. That's a strange word, we'll come to that. In the midst of the waters, and let it divide the waters from the waters. And God made the firmament and divided the waters which were under the firmament from the waters which are above the firmament. It was so. God called the firmament heaven. And the evening and the morning were the second day. The erev and boker were the second day. Now the word for firmament is rakia, and it's a strange word. In the Hebrew, rakia means an extended surface. It's an expanse, but it's a solid expanse. That's the emphasis of the word. In the Greek translation, steroma also means firmness, and it's from that the Latin got firmamentum, from which we get the word firmament, which means a three-dimensional solidity or firm expanse. And that sounds like a contradiction, because it's firm and yet it's term. We would say space, but it's not empty. So that's the second day, and we have, when it speaks of waters, by the way, I suspect that what it's dealing with is what's called in rhetoric a stenectiki. Often you put the general for the specific or the specific for the general. For example, you say, speaking of a very good hospitality, she sets a fine table. You don't mean literally the table, you mean the whole cuisine. See, that's an example in rhetoric where you use the specific to mean the general. Or, boy, so-and-so's got some neat wheels, meaning his car. So we use those synecdoches all the time. When it says waters, I think it's talking about fluids, and one of the things most of us think of matter as having 3 states: gas, liquid, or solid. There's a 4th state of matter, plasma before gases, and then gases to liquids to solids, or going the other way, from solid to liquid to gas to plasma, where you've got disassociated atoms. And I believe that's what's in view here. Is this more than a metaphor? All through the scripture, it speaks of the heavens being stretched. God stretches out the heavens, stretching out the heaven like a tent curtain. You can't stretch out empty space. That doesn't make sense. He stretches out the heavens like a curtain and spreads them out like a tent to dwell in. He stretched out the heavens. The Lord who stretches out the heavens in Zechariah. And we could go on with dozens of verses that are consistent in presenting this rather fluid role there. And we now discover, by the way, that empty space is really an oxymoron. Space is not an empty vacuum. It can be torn, according to Isaiah 64. It can be worn out like a garment. Space can be worn out like a garment in Psalm 102. It can be shaken. How do you shake empty space? Hebrews 12, Haggai 2, Isaiah 13. It can and will be burnt up, according to 2 Peter 3. In Revelation 6, it says it's split apart like a scroll. That's interesting. It can be rolled up like a mantle, according to Hebrews 1 and Isaiah 34, or a scroll. Now that rolled up is a clue here. In order for something to be rolled up, there must be a dimension in which it is thin. You can take a map and you can roll it up. That's because it's thin, and it also, a two-dimensional map needs a third dimension to be rolled up. So this is a hint of another dimension. Space can be bent. So there must be a direction that it can be bent toward. So thus there are additional spatial dimensions. And so we just know this from the biblical text, but we also know it as we understand what the physicists tell us about our universe, is that we now know that we live in more than 3 dimensions. In fact, more than 4, counting time as one of those dimensions. In fact, the current conjectures that we live in at least 10 different dimensions. So Nachmanides in the 12th century, by studying Genesis chapter 1, concluded that the universe has 10 dimensions and only 4 directly knowable. That was his comments in his commentary on Genesis. Well, it's interesting that we've spent millions of dollars on atomic accelerators to discover the same thing. Particle physicists in the 20th century have concluded, since about 1984, that we live in at least 10 dimensions. 4 directly measurable, 3 spatial dimensions, length, width, height, and time, and 6 other dimensions are curled, as they would say in vector calculus, curled in less than 10 to the minus 33 centimeters, and therefore they're only inferable by indirect means. And I think it's funny that we spent all this money on atomic accelerators to learn what Nachmanides did by doing his homework in Genesis 1. But moving on, let's talk a little about the atom. Most of us had some exposure to the atom. We think of the simplest atom, which is hydrogen, has a nucleus and has an electron running around it in the conventional representation of that. But there's a nucleus and there's an electron or more, and they're obviously in balance, plus and minus wise. But then this is obviously not to scale, because the atom is about 10 to the minus 3 on a scale, and the nucleus of the atom is about 10 to the minus 13th away. So that means, by the way, that there is the difference, the amount of space there, linearly is about 10 to the minus 5. If you take that volumetrically, that means that for every part that is particle there, you have 10 to the 15th emptiness. 10 to the 15th is a big number. If we were going to build a model of the atom, and we're going to let the nucleus be the size of a pinhead, the electron would be a football field away, literally 100 meters away. So an atom is mostly empty space. There's only one part in 10 to the 15th that is, in some sense, solid. But because of the electrical effects, it creates the illusion of having physical properties. And so we have H2O, where oxygen captures 2 hydrogen atoms, or we have other atoms where the whole hydrocarbon world is one of chaining these atoms by the electrical interactions of the atoms themselves, by imbalances. What seems to be suggested is, in the first early days of Genesis, is that we had plasmas. They hadn't even formed molecules yet. And we have the properties of space. By the way, something else I should go on to. Space has properties. It has an electrical property called permittivity. It has permeability. It has magnetic. Both has a dielectric constant and it has a magnetic constant. There is an intrinsic impedance in space. Any radio amateur who's been trying to tune an antenna knows that space itself has an intrinsic impedance. And these things are all now well understood. Of course, the velocity of light, as we've talked about, at creation was probably 2.54 times 10 to the 10th times its present velocity. It's currently also at the speed of gravity, which is a whole other thing to get into. Let's talk a little bit about zero-point energy. If the temperature of an empty container is lowered to absolute zero, there still remains a residual amount of thermal energy that cannot by any means be removed. That's why they call it the zero-point energy. An absolute vacuum is now known to be a vast reservoir of seething energy out of which particles are being formed and annihilated constantly. It's sort of like the foam at the base of a waterfall. See, one of the questions is, why doesn't an electron that's spinning around its nucleus of an atom radiate its energy away and by losing that energy spiral into the nucleus? It's a question. The answer is it picks up energy from the background zero-point energy and therefore is sustained by it. And that's exactly what's suggested in 1 Colossians chapter 1, verse 16, incidentally. But let's keep moving here. Day 1, let light be. Second day, the stretching out of space. The third day, we find land and vegetation. Now that's kind of exciting. So Erev and Boker on the third day leads to the land and vegetation.
You've been listening to Dr. Chuck Missler, teaching through his series entitled Learn the Bible in 24 Hours, here on 6640. If you would like further information about materials available from Dr. Missler, please contact us through this station or visit our website at khouse.org. Until next time, when Dr. Missler continues this series, may God bless you with the knowledge of His Son, Jesus Christ, as you study His Word.